Good morning, one and all. Today I'm here to. I'm from. Good morning, one and all. I'm from. Good morning, one and all. I'm Vishal. I'm from Triple A branch. I'm here to explain about an open system approach to power system protection and control integration in the power system protection subject. So here, an open system approach to power system protection and control integration means So the an open system approach to power system protection and control system integration is the majority of the protection principles currently employed in protection relays were developed within the first 3 decades of the last century, such as overcurrent, directional, distance, and different protection. The development of modern science and technology, especially electronic and computer technology, promoted the development of relay technology such as materials, components, and the manufacturing processes of the hardware structure of relay protection and device. At the same time, great theoretical progress had been in the relay protection, software algorithms, etc. The progress in modern technology stimulates the development in power system protection. In the last century, from the emergence of protection to the end of the 1990s, the relay protection had gone through a number of development stages, migrating from electromechanical to semiconductor and subsequently to integrated circuit and microprocessor technologies. Today, microprocessor based digital and numeric relays are replacing conventional relays in all areas of power system protection. However, many of the same relaying principles of protection are still playing a dominant role playing a dominant role to date. In the late 1960s, the application of a centralized substation protection system had based on a centralized computer system was proposed. This constitutes an important milestone in the history of power system protection. The idea fits well with the concept of an overall integrated protection where the based on the application of digital technologies. The introduction of microprocessors into protection in the 1980s generally followed the conventional approach with the implementation of distributed processing platforms that concerned on protecting individual units of the system. Limited integrated protection was provided in the form of backup protection and thus remained a secondary function. Secondary function. The adaptive protection started with the application of inverse definite minimum time over current IDMT protection in the early time of protection history. The concept played an important role in the 1980s with the progress of computing technology and associated control theory. It can be defined as a new type of relay protection which can change the performance characteristics or set value according to the operation mode and fault condition of the power system. The basic data of adaptive relay protection is to protect the power system as much as possible to improve the performance of the protection. So here we can see the graph. We can see the graph in 1990. It was it was growing in 1970 to 1990. It was still growing in traveling adaptive and artificial intelligence. In 2000s and 2010s, it has grown to a new development where it is now integrated wide area for P and C. So adaptive relay protection has the advantages of improving the response of the system, enhancing the reliability, and improving the economic benefits. It has a wide application prospect in the field of distance protection, transformer protection, generator protection, and so on. Research has discovered that to achieve the protection of the system adaptive to the operation mode and fault status, more detailed system operation and fault information are required through communication network. The 1990s witnessed the 1990s the witnessed the rapid development of electronic and computer technology, the artificial intelligence technology such as artificial neural networks, genetic algorithms, evolutionary algorithm, fuzzy logic and other research applications which have been applied to the field of relay protection. For example, artificial neural network (ANN) is used to achieve fault type identification, fault distance measurement, direction protection, and so on. So, an artificial neural network has the characteristics of distributed storage, parallel processing, self-organization, and self-learning. The application of artificial intelligence will improve the speed and accuracy of the fault detection and analysis, which represents the future development of an intelligent diagnosis system. As a result of this development, the performance of the protection windows has been improved. However, these developments have concentrated on the improvement of conventional relaying techniques, and significant new relaying principles have been derived from the application of the adaptive and AI techniques. At the same time, in the 1990s, with the continuous expansion of network power network, the demand for fast fault clearance to improve system stability encouraged research into non-power system frequency fault detection techniques to increase the speed of the relay response. This led to the development of the so-called transient-based protection relays based on traveling wave and superimposed component, which utilizes the fault generator transients for transmission system protection. Another important milestone is the application of novel communication technique, the utilization of global positioning system (GPS) in power system protection. In this respect, a number of new techniques has been proposed. In particular, the new proposed protection relay principle is able to provide protection for wide area power network. Following the development, the concept of wide area protection focusing on control aspect has been presented. Recent development in power system protection and control integration. So, the power system control and wide area control in recent years, particularly in the wide area and integrated protection. Recent development wide area protection in recent years. The fast development in communication technologies makes the wide area information exchange possible. In this respect, the emergence of the wide area measurement system provides a new idea for the design of power system protection systems. The first wide area protection principle is derived from the transient-based protection in 1996, in which GPS time synchronization played a major role in the design. This was immediately followed by a summary paper in 1997, which systematically outlines the concept of the so-called wide area protection, focusing principally on the control aspect of the area. The wide area protection based on novel algorithms, which is derived from the measurements of multiple information points to provide fast, reliable, and accurate fault clearance, analyze the effects on the system stability based on the fault treatment process, and take necessary control measures to perform the functions and for relay protection, security, and stability control in order to prevent voltage collapse. Wide area relay protection has quickly become a hot research topic, with many research results published, particularly in recent years. The development of digital technology, more and more protection functions for any given operators, line, transformer, generator, etc., have been implemented within one protective device to achieve a certain degree of integration. For example, a numeric line protection relay may have distance or current differential function as the main protection, the directional and overcurrent functions as the backup protection. The recent development in microprocessor and communication techniques provided new means to derive new protection principles and schemes based on the information obtained from multiple power plants and components, which could have significant advantages over the existing protection information obtained from the multiple power plants and components. Protection techniques based on the individual plant or component. Based on the developments mentioned above, a new concept of integrated wide area protection and control has been proposed recently. The main focus of the concept is the integration between the protection and control. They are supported by the specially designed real-time synchronized wide area communication, which receives real-time synchronized data from the communication network to support the integration protection. Information The information platform also supports application of a cloud computing system. With the proposed platform, the architecture of future substation equipment may be reshaped to provide a flexible framework for building an interactive grid and subsequently improve the reliability. There have been fast developments in both power transmission and distribution networks. The series compensation in AC lines and high voltage DC lines in transmission systems, distributed generation and energy storage in distribution systems. These new developments result in far more complicated characteristics of conventional systems will no longer be effective to cope with the new systems, and this has led to the proposed system version. There is the integrated multiple function intelligent intelligent equipment at the local level. Thank you so much.